The ionization energy is the energy that's required to remove one electron from the atom. I have the atom sitting here, and I'm trying to steal one electron from it. So, for example, I have a calcium atom, or a sodium atom, or a potassium atom, or whatever kind of atom, even any type of atom, and try to steal one electron or remove one electron from it. But where do we remove the electrons from? So if I have a sodium atom, it has 2 electrons in the first energy level. It has 8 electrons from the second energy level, and 3 electrons in the outermost energy level, which we call the valency electrons. Where do I take the electrons from? Every time I take electrons, I take it from the outermost shell. So I don't try to take the electrons from this or this. I take it from the outermost shell. So when you remove electron from the outermost energy level, you will spend some energy. You need to spend some energy. What is the name of this energy? Ionization energy. Why it's called ionization? Because the atom changes into an ion. The atom changes into an ion. Before you remove the electron, before you steal the electron, it was a neutral atom. It was a neutral atom. How did you know that? Because it has 11 protons and 11 electrons. So number of positive protons is equal to the number of negative electrons. So it was a neutral atom. But now that you have removed an electron, it will be a positive cation. It will be a positive cation. It will be a positive ion. Because the number of protons for sure will be more than the number of electrons, the positive protons. That's why it changes into an ion. That's why we call it the ionization. The energy that's spent in doing that, it's called ionization energy. Okay, how much electrons do we remove? I remove only one electron. That's why it's called the first ionization energy. What is the meaning of first ionization energy? It means you have removed only one electron. The energy spent to remove one electron. But, Mr., do you remove it from one atom only? Or you are speaking about the energy which is removed from 2 atoms or 10 atoms? No, I'm speaking about the energy that's removed when you take electrons, 1 electron each time from 1 mole of atoms. But wait, what is the meaning of 1 mole of atoms? It means that you have tried to remove electrons from 6.02 multiplied 10 to the power of 23 atoms. You change N into Na plus, Ca into Ca plus, not Ca plus 2 or Ca plus 3 or Ca 4 or anything. It's Ca plus. Why? Because when you remove the electron, you change the number of atoms. You change the number of electrons from 11 into 10. From 11 into 10. So now you have 10 electrons and 11 protons. So it's plus 1 sodium. What about calcium? If you have how many electrons in the calcium? Let's say potassium, calcium, sodium. Let's say magnesium. It's easier for you to find the number. Magnesium. Magnesium is in group 2. It has 12 protons and 12 electrons. You will remove, Mr., this is the first ionization energy. So we write it down. How do we write the first ionization energy? We say IE1. What does IE1 represent? IE, ionization energy number 1, first. So this is the first ionization energy. We write it IE1. How many electrons you removed? Only 1. So it becomes Mg, 12 protons and 11 electrons. So the protons is more than the electrons by 1, so it's Mg plus 1. Mr. Wait, but Mg is always Mg plus 2. Yes, it's always plus 2. But I said I removed 1 electron. I removed 1 electron, so it becomes Mg plus 1. That I can remove 1 electron or more. So I can remove the second electron, and it will be called the energy required to remove the second electron, or I can abbreviate it into IE2, the second ionization energy, or the energy required to remove the second electron. Or I can even be more greedy and try to remove the third electrons. But every time you will start first by removing the first one. So you cannot remove the third without removing the first. And every time you start from outside to inside. So you cannot remove electron if this is the nucleus from deep inside before removing the outermost electrons. So as a guide to the thieves, please try to remove the first electrons at the outermost shells or the valency electrons first. Once you are done, you can start looking for the inner ones. So again, this video is not a guide for thieves or not encouraging you to do anything bad. This one, if you try to remove electrons from the sodium, don't go for the first two or the next 8. Go for the outermost one first. Once you are done, you can think about stealing one electron from this 8. You can steal one of them, 2, 3, 4, 5, 6, 7, 8. Once you are done with these 8 electrons, now you have removed 9, you will go to ionization energy number 10, which of course will be a very difficult task. So we agreed upon that. The energy required to remove the first is not exactly equal to the energy required to remove the second. You make more energy now to remove the second and third. Every time you look at the equation, you will have to write the status, the physical state as gas. It's very easy to remove the electrons from the atoms when they are in gaseous state than removing it when they are in solid or liquid state. So when you write the equation of the ionization energy, write G in the atoms and G in the ions. And electrons are lost, so you write them in the product. Don't write them in the reactant. When you remove an electron from the Mg+, it becomes Mg plus 2. If he asked you about IE2, but if he asked about IE1, don't start with Mg+, start with Mg. What about the third? Start with Mg2+. This is the same atom that you remove 2 electrons from in 2 steps, not in 1 step, in 2 steps, and you became Mg2+. Then you remove the third electron. Don't write 1 electron, 2 electrons, 3 electrons. Every time you are removing 1 step at 1 electron at a time. Okay, can I ask you, Mr. a question? Can I summarize everything that happened so far in one equation? Can I summarize it? Yes. Actually, I need to remove this picture and put it. I can mention the 3 steps in 1 step. I can mention the 3 steps. But let's note that what happened here first. The calcium has removed 1 electron to form the calcium plus and E. And every time you are speaking about G, gaseous state. And you are speaking about 1 mole of gas. So this is our nice thief. And we will try to know some questions that we will answer, but let's see first one small note. She wake up at the end. Finally, she started noticing what's happening, and she's trying to fight back. Maybe after 2 or 3 electrons has already been removed. Now the things get difficult. Why? You are trying to remove the electron from somebody who is already has lost. So if you are the same thief and you are coming to steal from the same lady, the next day she is going to be more alert and your job is going to be more difficult because she started to notice what's happening. Okay, let me ask you a question which comes a lot in the exams. What does the question say? The question says, is it easy to remove an electron from an atom or from an ion? An atom or an ion. So, Mr. You try to remove the first electron from the sodium. It was 281. And you try to remove the electron from it. And you try to remove the electron from the Na+. What happened when you lost an electron? It become Na+. So it is 1A2. No, it's 2A. So I'll stop the record here. The question that comes a lot of in the exam. Is it easier to remove the electron from the atom or from the ion? What does this mean? When I removed an electron from the sodium at the beginning, it was neutral because the number of protons in it was equal to the number of electrons in it, both of them 11. And when I removed the second electron, actually I was removing the second electron this time from a positive ion, because when it lost an electron, it became a positive. So which is easier? It is the same as saying that when you remove an electron, from the sodium atom and sodium atom, it's like trying to check the attraction between this magnet number C and this magnet number A, and the attraction between this magnet number C and a block called B, which has no charge at all. There is attraction between A and C. The negative in C is attracted to the positive in A. But there is no attraction between the negative of C and the P, because P is uncharged. So it's very difficult to remove this C from A because they are attracted. The plus here is attracted to the negative here, but the negative here is not attracted to here. So here is stronger attraction. It's difficult to remove it. And B to C is weaker attraction. The same thing happens in the sodium atom and the sodium ion. You are trying to remove the electron here from a neutral atom. There is no attraction. The attraction is there. Actually, it's a weak attraction. But what here? Here there is plus ion and the negative electron. So the same like A and C, plus and minus. They are attracting each other strongly. So the attraction between the electron and the positive ion is much stronger than the attraction between the electron and the neutral atom. That's why removing the electron here is a much difficult thing than removing the electron from here. That's why the IE2 is much higher than the IE1. The energy that you will spend to remove the second electron is much higher than the energy that you spend in removing the electron number 1. The unit of ionization energy is in kilojoule. This is the amount of energy. I spent 590 kilojoule. 590 kilojoule. Per what? Per 1 mole, Mr. of atoms. So every atom, you are removing 1 electron. But how many atoms? Is it 10? Is it 5? It's 200? It's 1 kilogram of atoms? It's 1 mole. So 6.02 multiplied by 10 to the power of 23 atoms of this element has been robbed of their first electron from the outermost shell when they are in the gaseous state. Next question. This reaction actually is an endothermic reaction. Why it's an endothermic reaction? Because you are breaking a bond. And last year, and in energy, we took that whenever you break a bond, you are making an endothermic reaction. Since it's an endothermic reaction, it's going to be 590 kilojoules plus, not minus 500 kilojoules, minus if it is an exothermic reaction, when you are making a bond. But here you are breaking a bond between nucleus and electron. And we knew that whenever you break a bond, the energy is endothermic. The next point is, what happens if you are breaking a bond? How do you write the equation? So when you write the equation, you have to put the amount of energy that's absorbed or released. It's absorbed, yeah, mister. Why it's absorbed? Because it's an endothermic reaction in the reactants to show that it is an endothermic, that it is absorbed in the reaction. You can write an equation summarizing what happened by saying you started by mg, and the total amount of energy absorbed in both cases is just by addition of the two values of IE1 and IE2. This is IE1 plus IE2 to form mg2 plus. This is the final product. It's like when you are writing multiple equations, multiple steps, and reaching the final step. So you reach to mg2 plus from mg. This is the summary. And you lost 2 electrons. Why you didn't write 1 electron? Because we are not writing step by step. We are writing summary of the total. How can you know the element group from the ionization energy values? We'll explain the reason next session, but let's see now how we can do it. Just look at the numbers of the ionization energy. This is the first ionization energy, 736. This is the second, 1445. This is the third, 7730. Try to look at the biggest jump. How can I find the biggest jump easily, Mr.? Just subtract the number from each other. This is almost 700. Then subtract this one. Can you see how big is it's almost 6,000? It's almost 6,000. This is a very big jump. What to do next? The jump is between the first number, just number them 1, 2, 3, 4, 5, 6, 7. The biggest jump between number 2 and 3. Take the left number. Take the left number. This is the group number, so it's number 2. So magnesium is in group 2. Now, this element is aluminum. In the exam, he might not give you the element name because he knows if you give you the element name, you will just go to the periodic table. He might just say element X. So the biggest jump here, try to subtract. It's almost 900. Here, it's almost 900. It's almost 900 again. It's almost 9,000. So the biggest jump is between number 3 and number 4. Take the left one, number 3. So it's in group 3. So always take the left number between the biggest